Hello GCC, welcome back for continuing coverage of Chapter 10. We're going to talk about combustion reactions now. So remember, combustion reactions are with hydrocarbons, chemicals that have a carbon and a hydrogen in them. So I want you to write the combustion reaction for propane gas C3H8. Hopefully you remember what has to be added to support the flame, and hopefully you remember what the two products are. So hit pause and see if you can write this reaction. All right, good job. If you got C3H8 gas, because it's propane gas, plus oxygen gas, we need oxygen to support the flame. So plus O2 gas, then the arrow. And our two products, if you remember from the previous video, are always CO2 gas and H2O gas, because it's hot, it's fire, so the water is boiled and it's in the gas state. It's hot and it floats away with the CO2. So that is the reaction. C3H8 gas plus O2 gas makes CO2 gas plus H2O gas. Now we have to balance this. There's a trick for balancing combustion reactions. You need to do the oxygens last. So let's look. There's 3 C's on the left side. So we need to put a 3 in front of CO2. So we'll have 3 C's on the product side. Then there's 8 H's on the reactant side. So we're going to put a 4 in front of H2O on the product side to have 8 H's over there. Then we will count up all of the oxygens on the product side, which I believe will be 6 plus 4 is 10 oxygen atoms. So what do we need to put in front of O2? To make 10 atoms on both sides, we need a 5 in front of O2. And so we get our balanced reaction. C3H8 gas plus 5 O2 gas makes 3 CO2 gas plus 4 H2O gas. So that's a typical combustion reaction. Now you have to write the products for this one. I will not give you CO2 and H2O. You have to remember the products are CO2 gas and H2O gas. So we call that predicting the products, meaning we, the instructors, are not going to give you the products. You have to figure them out on your own, predicting products. Make sure you also watch the predicting products videos. So combustion reactions. We're only doing combustion of hydrocarbons, CH chemicals. Balancing tip, do oxygen last. Products are always CO2 gas plus H2O gas, and O2 gas is always a reactant. You should be able to predict the products for these, as I just mentioned. This means we give you the hydrocarbon, that's it. You have to write the rest of the reaction. You have to remember the products are CO2 and H2O gases. Try one on your own. Write and balance the combustion of C2H6. Pause. Do this on your own. All right. Did you have some trouble balancing this one? Yeah, let's talk about that. First of all, let's write the reaction. C2H6 gas plus O2 gas, oxygen supports the flame. Arrow, products are always H2O gas plus CO2 gas. It doesn't matter which one you write first, by the way. You could put H2O gas, then CO2 gas, same thing. Now for balancing, we have C2H6, so 2 carbons, so you put a 2 in front of CO2. Okay. H6, 6 hydrogens, so you put a 3 in front of H2O. So we have 6 hydrogens. However, that gives you 4 plus 3 is 7 oxygens. What can you put in front of O2 to give you 7? Well, nothing. So we get stuck. So what are we going to do when we have an odd number of oxygens, but O2 is an even number? Well, we're going to double everything. So again, the problem with the oxygen being odd and even on the two different sides, so double everything. 2 C2H6s. Then we can have 7 O2s, making 14 O's, making 4 CO2 gases plus 6 H2O gases. So let's look at the balanced reaction. We have 4 carbons on both sides. We have 12 hydrogens on both sides. And then we have 14 oxygens on both sides. All right, I hope you're able to keep up with that one. Moving on to acid-base neutralization reactions. As we mentioned, we're only doing Arrhenius acid-base reactions, so the products are always going to be water plus a salt, which is an ionic compound, a metal and a nonmetal, which means we have to check our charges. The acid has an H in front, HA for example, that's generic. And then we have a metal with hydroxide, so OH in back. H in front, OH in back makes HOH, H2O, water. We're going to make water when we have acid-base neutralization reactions. Now, balancing tip. For the water, when we balance it, we're going to pretend instead of H2O, it's HOH. And then we can balance the hydroxides on both sides because we want to balance polyatomic ions when we can as a group. So let's look at our 2 examples. Let's complete these reactions. HCl, that's an acid, it has an H in front, plus barium hydroxide. We have an OH in back. So we're going to make water. H2O liquid is one of the products. And then what's left over? Barium and Cl is left over. So which goes in front, Ba or Cl? Well, the metal goes in front because whatever's positive goes in front. So barium's going to go in front. Ba, then Cl. And is that the formula? Just BaCl and put them together? No, we have to check the charges. Ba is a +2, Cl is a -1. 2, 1. That doesn't add up to 0. We're going to need 2 Cl's to go with the barium, which is a +2. So the formula is BaCl2. And to balance it, let's balance it. If you pause if you need to balance this reaction real quick. And so we're going to need 2 HCl's with 1 BaOH2, and we're going to make 2 H2O liquids and a BaCl2 aqueous. Okay, again, you have to predict the products for these. So that's why you need to watch the predicting products videos. That will help you with this. Again, the Ba and Cl come together, we check the charges. That's where the 2 came from. And then because there's 2 OHs, we need 2 OHs in the water. Remember, we're going to think of water as HOH. There's BaOH2, 2 OHs, so we have to put a 2 in front of the water to give us 2 OHs. That gives us 2 H's, and thus the 2 in front of HCl. All right, I want you to try the last one on your own. H3PO4 aqueous plus CaOH2 aqueous. I want you to write your products, states, and balance. Okay, those are the 3 steps. Write your products appropriately, check your charges. Write your state, solid, liquid, gas, aqueous. Check your charges again, and then last is balance. All right, so for H3PO4, phosphoric acid, plus CaOH2, calcium hydroxide, we're going to need 2 of the acids with 3 of the bases, and we're going to make calcium phosphate, which is Ca3PO4 in parentheses 2. It's a solid, according to our solubility rules, and 6 H2Os, 6 waters, which are liquid. Remember, now that you're writing products, you may have to look up your ionic compounds in the solubility rules. Calcium phosphate, according to our solubility rules, is a solid. Solubility rules are in Chapter 9. If you need to, go refresh yourself on solubility rules, Chapter 9. Calcium phosphate is a solid. All right, that's it for this video. We'll come back and work on single replacement reactions after this. Goodbye, GCC.